Okay, in section 10.3.5, review and preview problems, 177. At 10 a.m., a radioactive material weighed 2 grams, but at 6 p.m. it only weighed 0.45 grams. What were the approximate hourly multiplier and the hourly percent of decrease? Okay, so a radioactive material means we have exponential decay, and we are going to have an exponential equation that looks something like this. We need to find our A and our B values. Do we have our starting value? Yeah, we have a starting value, which is our A value is our starting value. And they tell us at 10 a.m. it weighed 2 grams. So that's our starting value. We already know our A is 2. But we don't know our B value for our equation. And that's what they're asking about. But we do have a data point, right? At 10 a.m. it was 2 grams, but at 6 p.m. it was 0.45. So how many hours is that? Let's see, that's 8 hours. After 8 hours, it weighed 0.45. So our Y value is 0.45, and our X value is 8. Okay, so we need to solve this equation. So I'm going to divide both sides by 2 and get 0.225. And now I have equals b to the 8. How do I undo that exponent, that 8? I'm going to raise both sides to the 1/8 power. 0.225 to the 1/8 power, I'm going to put into my calculator, and I get 0.8299 equals b. That's about, since they said, that's about 0.83 as our b value. It's close enough. So that's our hourly multiplier, would be 0.83. And the hourly percent of decrease is going to be 1 minus that value. So 0.17, so the percent decrease is 17% that it's decreasing every hour. All right, problem 178. A triangular prism has a volume of 600 cubic centimeters. The base is a right triangle with a hypotenuse of length 17 centimeters. Okay, so we're going to test my drawing skills here. We have a base. Okay, that's not too bad. Here's our prism. Oh, and those would be solid lines, right? And the base is a right triangle. The hypotenuse is 17, and one leg is 15. First, draw the figure. Okay, there's my best effort. And they want us to find the height. Okay, well, what do we know? What relationships do we know? We do know that the volume of a prism is the area of the base times the height. And we know the volume is 600. What is the area of the base? Well, we need to find this other leg first. What's that leg? And we'll call this h. Well, we do know, let's see, 17 squared equals 15 squared plus x squared using the Pythagorean theorem. I subtract 15 squared and take the square root. And it turns out this is actually a Pythagorean triple. And this other side is, I get that x equals 8. Right? Okay, so the area of any prism is the area of the base times the height. Well, what is the area of our base? It's a triangle, so it's 1/2 base times height of our triangle, the two legs, right? 8 and 15 are our base and our height, times the height. So let's see, 1/2 times 8 is 4 times 16. I get 600 equals 60 times h. And I divide both sides by 60, and I find that h equals 10. Because the height of my prism is 10. Now I need to find the surface area. Okay, well, how many faces does this have? This has the top and the bottom. And then around the sides, let's see, I have this one in the back, and I have this one over here, and then I have the front face. Okay, so there's 5 different faces. And the top and the bottom, so the area, the surface area is going to be the top, which is 1/2 8 times 15, plus the bottom, plus, let's see, each of these is a rectangle. 17 times 10 is going to be the area of that rectangular side that's facing me, plus 15 times the height is going to be the one over here. And then the one over here will be 8, times 10. And let's see, if I multiply those out, what do I get? It's going to be 60 plus 170 plus 150 plus 80, and I get 520 square centimeters. Last thing, they want us to find the area of the 3 angles of the triangle in the base of the prism. Okay, so let's write this out. We have 17, 15, and 8. We already know this one angle is 90, obviously. Let's find this angle. Let's call it theta. And I could use any trig ratio that I want because I know all 3 sides, right? To find an angle, we're going to use an inverse trig ratio. And maybe I want to use tangent. I'm going to say theta is inverse tangent of what's opposite of theta, 15, and what's adjacent to theta, 8. Inverse tangent of 15 over 8, and I get 61.93 degrees for that angle. And I could also use a trig ratio to find this third one, or I could just use the triangle sum theorem and say 180 minus 90 minus 61.93, and I get 28.07. Okay, there's a lot to calculate there. We used the Pythagorean theorem. We used the area of a triangle. We used the volume of a prism was that area times height. We found the surface area by adding together the areas of triangles and the areas of rectangles. We used an inverse trig ratio to find an angle. We used the triangle sum theorem to find the third angle. I hope you guys are realizing how much geometry you have learned in the course of this year. All right, back on to problem 179. A pizza parlor has 12 toppings other than cheese. How many different pizzas can they create with 5 or fewer toppings? List all subproblems and calculate the solution. Okay, so let's start with 5 or fewer. How many with 5? Well, there's 12 pizza toppings, and I want to choose 5 of them. Can I repeat? No. I think for this problem, we're just going to count, peppers and mushrooms as 2 different things and not say that you could choose peppers twice. Does order matter? No, it doesn't, right? When you make a pizza, I don't care if you put the pepperoni on and then the mushrooms or whatever. So this is a combination. So the combination of 12 choose 5 is going to give me the number of different ways I could choose 5 toppings. Well, or fewer. What if I wanted to choose 4? There we go. It's going to be 12 choose 4. Or 12 choose 3. And 12 choose 2. And 12 choose 1. And 12 choose 0. All right, well, that's a lot of combinations we got to find here. So let's think about our formula. This is 12 factorial over 7 factorial, 5 factorial. This is 12 factorial over 8 factorial, 4 factorial, right? 12 minus 4, and 4. Here, 12 factorial over 12 minus 3 is 9, and 3 factorial. 12 factorial over 12 minus 2, 10 factorial, 2 factorial. 12 factorial over 11 factorial, 1 factorial. Plus 12 factorial over 12 factorial, 0 factorial. So let's just notice one thing. All of these denominators, 7 plus 5, 8 plus 4, 9 plus 3, 10 plus 2, 11 plus 1, and 12 plus 0, all add up to 12, right? Okay, so that's just a pattern to notice. All right, so now let's try to simplify these a little bit, or you could just put them in your calculator. But let's just practice using factorials. Okay, this is like 12 times 11 times 10 times 9 times 8. And then this is going to cancel with all the rest. So that's going to be all over 5 times 4 times 3 times 2 times 1. What do I have here? 12 times 11 times 10 times 9. And then 8 down to 0 is all going to factor with, or cancel with that. And then in the bottom I have 3, 2, 1. Okay, here I have 12 times 11 times 10, and then 9 to 1 is all going to cancel with that. And then I have 3 times 2. 12 factorial, this is going to be, this is going to be 12 times 11, 10 down to 1 all cancels, and then I have 2 times 1. Here I just am left with 12 over 1. And here I'm left with 1 over 0 factorial, which, from your math notes box, you know is 1. Okay, so let's try to cancel some of these things. Let's see, 4 times 3 is 12. 5 times 2 is 10. So here I have 11 times 9 times 8. 4 times 3 is 12. I could cancel that with a 5, so I have 11 times 5 times 9. 3 times 2 is 6, which leaves me with a 2. So I have 2 times 11 times 10. This goes into that, I get 6. So 6 times 11. Here I just have 12, and there I have 1. Okay, so I put these in my calculator. I get 792 plus 495 plus 220 plus 66 plus 12, plus 1. Add those all together, I get 1,586. Okay, so I don't want you to get overwhelmed by this problem, okay? This step right here is kind of optional. I think it's a little bit fun to cancel things with factorials, but you might not, and that's okay because you have calculators, and you could even put in just each of these. Your calculator can calculate all of these values, right? So you could go directly from here down to here to add those up, all right? Okay, we're getting close. Mike was asked to make his popular 10-layer dip for the tailgate party at the big football game. The 10 layers are 3 layers of mashed avocado. So there's 3 layers of avocado, 2 layers of cheese, and 1 layer each of refried beans, sour cream, sliced olives, tomatoes, and green onions. Okay, so 3 plus 2 is 5, 6, 7, 8, 9, 10. Yep, there's 10 layers there. The question is, how many ways can Mike make the 10 layers in a glass serving pan? Okay, I'll be honest, this is tricky. First of all, if we just made a decision chart, how many slots would we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that the right number? Yes, that's 10 slots. And we could say, well, there's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That would be 10 factorial. But this is a little bit tricky because, like, the avocado layers are really the same as each other. So we're going to have to divide by some things to account for the fact that we have 3 avocado layers and 2 cheese layers. Okay, the 3 avocado layers are all interchangeable. So we could divide by 3 factorial, and the 2 cheese layers are also interchangeable. So we could divide by 2 factorial, and we get 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 3 times 2 times 1 times 2 times 1. Let's see, this cancels with 6, and this cancels with 2, and I still have a bunch of numbers to put into my calculator. I put them in, and I get 302,400 different ways he could order the layers of his dip. All right, let's look at problem 181. Write an equation and use it to solve this problem. Jill has a 9-inch tall cylinder. Okay, there's our cylinder. It's 9 inches tall, and she's using it to catch water leaking from a pipe. The water level in the cylinder is currently 2 inches deep. Look at that. I used a blue just to be cute there. And is increasing at a rate of 1/4 inch per hour. how long will it be before the water overflows? Okay, so our starting value is 2. And what's our rate? Our rate is 1/4 inch per hour. If we multiply that rate times the number of hours, that's going to give us our height. And we're curious when it's going to be full. When it's full, what's the height going to be? 9. Okay, so there's our equation. The question is, how long will it be? Okay, let's solve our equation. Subtract 2. I want to undo the dividing by 4 by multiplying both sides by 4. So I get that my time is 28 hours. Problem 184. Calculate the total surface area and volume of the prism below. The bases are equilateral triangles. Okay, so if that's 8, if this is equilateral, that's 8 and that's also 8, right? And what do I know about the angle measurements of an equilateral triangle? They are all 60. I'm going to draw that triangle bigger. This is 8, that's 8, that's 8. This is 60 degrees. So I want to find the surface area and volume. Okay, so to find the volume of a prism, I need to know the surface area, the area of the bottom, the base, times the height. Okay, so what is the area of this triangle? Well, we've done this a bunch of times. I'm going to break this into 2 right triangles. This was 60 and I broke it in half, so now this is 30. Aha, I have a 30, 60, 90 triangle here. I could use sine, cosine, or tangent, or I could use properties of a 30, 60, 90 triangle. Notice that this number 4, right, when I split this base in half, this half of that base is 4. That's my good angle. It's one that's 60 degrees. So I know that this, the hypotenuse, is twice as long, sure enough. And I also know the height. What is the height? 4 times the square root of 3. So I could find that using tangent of 60, or sine of 60, or tangent of 30, or sine of 30, or cosine of 30, or the Pythagorean theorem, or 30, 60, 90 triangles. All of those are ways that I could find the height equals 4 times the square root of 3. Okay, so what is the area of my base? It's going to be 1/2. Here's the base of my triangle, times the height, which is 4 square root of 3, times 4 square root of 3. I put that into, I could multiply these out. My exact answer would be 16 times the square root of 3, which is 27.713 if I put it in my calculator. All right, that's the area of one base. Okay, so what is the volume of my whole cylinder? It is the area of my base, 27.713, times the height, which is 10. They gave that to us. So 277.13 cubic centimeters is the volume of my prism, the area of the base times the height. How about the surface area? Well, it's going to be the area of the bottom plus the area of the top plus the area of the 3 sides. And the nice thing is all 3 sides are going to have the same area, which was going to be 8 times 10. They're all rectangles, right? 8 times 10 is 80, plus 80, plus 80. All right, so I put those in my calculator and I get 295.43 square centimeters.